In this lab, we're going to put what we've learned into a little bit of practice. We're going to find a service and check for a vulnerability. And then from there, we're going to actually try exploiting it based on what we find. So let's jump into our environment and give it a look. Ran an Nmap scan with service enumeration on our target IP. And what we came across, start at the top, first port 80 TCP, it's plain old HTTP. And it's running on LAB2 2.7. The rest of this looks to be Windows, and it says it's a Windows Server 2008 R2 to 2012. And that's probably fairly accurate. We could get into that more if we want, but let's find out about this LAB2. Going to the IP address, looks like it automatically loaded some information for us, but this is LAB2, looks to be a file server. And you can upload files. Or there's this query right here. Alright, this looks like it could be something. What do we do if we want to research something? Well, it's 2022 now, so we go to Google. Looking at LAB2 2.7 for CVEs, we can come across the NIST page for it. And there we are, CVE 2007-6377 details. And looks like there is a stack-based buffer overflow in the pass-through functionality in extension.dll in LAB2 2.72 Bravo and earlier. Allows remote attackers to execute arbitrary code via a long query string. Now, some of that might not make a ton of sense to you right now, being that this is a junior penetration test course, but what we do understand there is we can run arbitrary code in old versions of this software that we are currently running on our target machine. Well, that seems neat. Anything else in here that we need to know about? We could get into the AltaVista advisory, and that's just the exploit. Get into the actual advisory, and that is an old page. Looks like this information is so old, we're not going to get anything great in here. Any extra in the analysis description? No. Basically, old versions of LAB2 2.7 and earlier have this problem. There might be new versions of LAB2, or there might be other ways of serving up these files. But in order to fully understand this, let's go investigate a little further. Might have seen I clicked over and that took us to an exploit. It might not have made a lot of sense. Here's exploit DB with an exploit for it. And let's navigate there ourselves. This is exploit DB, exploit database, and it's managed by our friends at Offensive Security. But anyone can upload their proof of concepts, their exploits here, and the community can then utilize them after they've been verified or at least submitted into the database. How it works, we have a search bar over here. There's some functionality over here. There's papers, which are helpful, shellcode, which is great. What I'm going to do is just start with what we know, LAB2, and it will update as we go. Ooh, looks like there are even older versions, 2.7. Because that's what our machine says. It's 2.7. Looks to be a denial of service. Okay, that's not going to help us, but it's good to note. It's also for 1.2.7. Same with this full path disclosure. It's 1.2.7. So probably not super helpful. 2.72 pass-through buffer overflow. This one's for Metasploit. Here is a non-Metasploit. Let's jump into that one and see if there is notes in the code. So your submissions to eJPTv look like this. Each has an ID, the CV that it's related to, the author for attribution, see what else they've made, what type of code is it, it's remote in this case, what platform does it apply to, and then you can download the vulnerable app if you really want. You can get the code, see it raw. This is the code. Straight, and this one is a Perl script. If you don't know Perl, that's fine. I don't know Perl either, but it's written in English, and if you've seen one scripting language, you've probably seen them all. Let's just try to make a little bit of sense out of it. Usually things that start with a # hashtag are just comments. We've got an if statement. It looks to see if it has arguments passed. It's going to say, hey, this is the usage, which is nice. It tells you how to use it. If you just type the exploit, I guess, or Perl and this file, and you don't give an extra argument, then it tells you, hey, you need to have a victim and a port. Okay, that makes sense. Probably our victim IP number and port 80 in our case. There's this Metasploit Win32 bind, and okay, looks like they used an L port of 4444, size of 709, this PEX alpha num encoder, and their exit function is SEH to create this shellcode. This is in hexadecimal. We'll get into hexadecimal and a lot more of the scripting in a later course, but we're just trying to see what's here. Okay, it said we needed a victim. This looks to be a variable with that $sign out in front. Java and Perl, I guess, both use that $. And it connects a socket over INET, so it's just going to connect to that IP address over TCP, utilizing our arguments and some other stuff. Okay, neat. Looks to be some extra code. Okay, some more functionality. With these buffer overflows, again, later courses will make a lot more sense here what they're doing in memory, but basically utilizing overflowing memory in order to run our own code. So what they do here is they overflow, then they jump around in memory until they find a place where they can run code, and then they run the shellcode that's there, uploaded on top of the rest of this. And it all gets passed via a GET request with that, okay, / exit ext.dll, and then some commands. Wait a second. We had that here. All right, / ext.dll, question mark, mfc, okay, command, and it tells it to do stuff. So the command is going to be passed through and then it's going to pass the rest of this stuff. Okay. Neat. We can go through and figure out how to use this manually, or there was a Metasploit one. We've got a whole course on Metasploit. Alexi took you through how Metasploit works, why it works, lots of great stuff. There's an exploit for it. So we could find this module and run it. While we're here, let's read about it and see what it means. See what it does. Metasploit modules are written in Ruby. I don't know Ruby either, as in I couldn't write Ruby. If you asked me to make this, I could figure it out eventually. But again, it's in English, so let's see if there's some things that make sense to us. We've got classes, okay. This is just a Metasploit exploit for remote. Great ranking, that probably means it works really well. Note, bad blue doesn't give any HTTP headers when requesting. That's good to know. However, a proper server header is returned when requesting index.html or using head. Neat. Okay. what it's going to pass us. This module exploits stack buffer overflow in 2.72b and earlier. It's good to know. Same CVE that we've seen before, and that same ID. Okay, we have some bad characters. Neat. We'll get into that again later course. Excited to talk about it, but not going to do it here. And then the exploit does some stuff. It offsets. A lot of what we saw in that Perl, this stuff doesn't make a ton of sense unless it's been explained. How is it passing it? Okay, it's got a URA /ext.dll question mark mfcis API command pass through and okay. Gotcha. So it's going to do that and all those things. Let's go play with it. There we go. Load up some MSF console. Search for Bad Blue 2.7. And there it is. Use 29. Info. Yep, targets Bad Blue and 2.72. Anything else in here? Same exploit we just saw. And we can set it with proxy chains. Don't need to. We need an R host. We need an R port. Don't need SSL because it's HTTP. And we need to set a payload. So Windows, probably x64. Nope. Interpreter reverse TCP. Sorry, sometimes Metasploit's smarter than I am. Set R hosts and still have that copied. I don't. Linux is neat when you do this stuff. Set lhost and eth1. That L port works. Everything with a yes has a yes. Let's run it. Okay, so it's sending, it's trying out the target, sends a stage, opens a interpreter session, and we are in the machine. Hey, we are on that Windows 2012 R2 and in a 32-bit interpreter shell. Oh, no, it shows 64. From there, we can do a lot, and Lexi goes into details on what you can do with Metasploit. Host network auditing, we will get into what else we can find on this machine. It's a Windows machine. There's a bunch baked into it that we can take advantage of. And from there, we'll see what else we can find. But we found a vulnerability. We found out that we could exploit it. Found a nice way of running that. Now, if you know Perl, if you could run the GET request yourself, if you knew Python or Ruby, you can set this up yourself. I didn't want to get into all that. We had a Metasploit module, take advantage of that Metasploit module, and it works. So however you want to skin the cat, we found a vulnerability. We found out that this machine is exploitable, and we can now go into more, enumerate, finish out the rest of our pen test. But this is something that we can include in our report. You had a server running this software that is vulnerable. Now, there's other versions of software. There's other ways of serving up those files. There's other options, and this might be internal. It should probably be firewalled. It might be firewalled, but if it's HTTP, then anything going across the wire, if there is a man in the middle, they could read and pull out any objects from those packets. There's just a lot in there that is worth noting and worth bringing up to your client, and a lot of remediation possibilities. Now then they could decide, okay, that's fine, this is internal, we have it firewalled, maybe that server is firewalled so only internal machines can get to it, and since we were VPN'd in, we have access. I don't know, but you bring it up, you identify it, you highlight it, and then it's up to your client to decide how they want to mitigate or remediate it. All we do is find and report. All right, with that, we're going to close out this one and move on to the next course.